Okay, so let me start my all the nodes. So right now I am using here one image, and what is that version? I can show you. The firewall is already running. Okay, and I hope this diagram is visible to everyone. So this is ASA-V. ASA is virtual ASA, and 9.6 version is this time. Okay, 9.61. So this version I am using here. So 0 by 0 interface is connected with my switch, that is the LAN switch. 0 by 1 with the WAN, and this is the DMZ. DMZ actually, this is demilitarized zone. So demilitarized zone is actually where we can install the servers and all. Okay, but we are not using today about this zone and all. So we will just make sure about the traffic pass through ASA from inside to outside. And I think now router 2. So I am starting with the configuration on the routers, so you are already aware, or maybe the configuration is already there. So let me wipe out for you, so you will see what configuration we are going to do. So whatever configuration I'm going to do today, I will save this configuration, okay, for next lecture also. So until the devices are going to boot, so we have already here Cisco firewall, and if the configuration is here, if you check the interface, show interface IP brief command. Okay, so till now we don't have any configuration and anything. Now I'm going to configure gig 0 by 0 interface first. So we need to move here, interface gig 0 by 0, no shutdown the interface, name if the interface. If I'm giving here inside directly, right, so inside automatically give the security level 100 to itself, okay, because as it mentioned. And now we can give IP address 10.1.1.10/24, okay. And the next interface is gig 0 by 1, name if is outside. So you can say if any other interface name you give except expect inside there is always security level 0. You can give manually if you want to give with this command, okay, but here we don't need to require. IP address, okay. So we have configured here, and if you check, let me give the host name ASA, and show interface IP brief, and you can check we have now IP address, and even both routes are visible into the routing table. So the command is show route, okay. So you can check show route command have interface name instead of the number of the interface, gig 0 by 0, 0 by 1. No, the number is not required, name is required actually, okay. So this is the main reason, that's why I told you the name if is very important, okay. Now we have configured the both interfaces, so we have not doing anything else. So now time to configure the R1, so I can pass the traffic and show you that, okay. I can pass the traffic and show you. So the host name is R1, interface is 0 by 0, no shutdown, IP address, .1, okay. And we need to give here one default route so it can reach to the 20 network. I configured it, and let me try to ping the ASA. So yeah, ASA is reachable, similar on R2. Host name is R2, interface is 0 by 0, now shut down IP address 20.2/24, and we can give here also default route, so it can reach to 10 network, and next stop is firewall outside interface. Okay, and I need to enable here some services also, so I can give here username. Username is not required. Okay, I can give admin privilege. Okay, IP HTTP server, IP HTTP authentication local. Okay, and I need to enable login local, transport input all. Okay, yeah, that's enough. And now I'm on R1, right? So on ASA, the first thing, ASA have some global policies. So those global policies we can use to inspect the traffic. So by default, TCP UDP traffic is TCP and UDP traffic is inspected by default. Okay, but make sure not because of global policies. If you remove the global policies, still your traffic will inspect. So that is by default inspected. Okay, so in global policies we can inspect maybe IP traffic, or we can inspect some other traffic. We will see how we can do that. Okay, but try to understand, TCP UDP traffic is inspected by default. That is not because of global policies. Okay, so if you remove the global policies or you change the global policies, it will not affect anything. And how to check the global policies? Show run policy map. So here you have policy map, you can see. So this is your global policy. Okay, under that you have here one class map, which is with inspection default. Okay, so you are inspecting here FTP traffic. Okay, and RSH, RT, TFTP and SIP traffic, right? But there is nothing like telnet, SSH or TCP traffic. Why? Because that is not part of it. And you have here one global service policy for that is applied, and you can check service policy global. So that is by default here, right? The global policy. But this global policy is not inspecting your TCP and UDP traffic. Okay, but whenever I'm going to pass the traffic, so it will automatically inspect, and it will show your entry into the connection table in con table. Okay, so for that, what I'm doing, I'm going to do the telnet 20.1.1.2. Okay, so you can see the traffic is passing, and we have admin and Cisco, right? So now you can check if I have connection. If I have continue connection, I have here one entry, guys. So try to understand, we have one entry here. So the traffic is TCP sent to outside interface to IP 20.2 on 23 number port. Traffic is coming on inside interface with IP 10.1 with this random port number, right? This is the timer and the bytes, and we have here flags. So we have three flags. Up means like the session is up. I means inbound. Okay, so that means inbound traffic which come from outside to inside. Okay, and outbound traffic which go from inside to outside network, that is outside. If you do show con long, okay, with this command you will see here the logs and all these things in detail. The same thing here you have, okay, outside with this, inside have this, but you can see your flags. And where is the flag? Wait, come on. We have UIO, right? So O means outbound. Outbound is always which traffic, guys? Make sure outbound means which initiated from higher to lower. Which initiated always higher to lower. That is outbound traffic. Okay, that is going to outside network. Okay, and if there is I is inbound. Where is capital I? Inbound data, right? So inbound means when traffic is coming from higher lower to higher security level, that is inbound. That is inbound, right? Okay, and U is up. Up means the connection is up. Okay, so that how you can check. So this connection, this con table create or remain your entry whenever traffic is passing. But once your session is done, like if I'm going to delete here the session, what I'm going to do, I'm going to exit. So at the same moment it will remove the entry or not. Let's see. Yeah, there is no entry. If you check con table, there is no entry. So con table create or remain the active entries. If once your session is done, so the entry is no long. Okay, entry is no longer in the table. Are you getting my point, everyone? Guys, okay, so this is about telnet. Okay,
Yes, yes.
and now what I'm going to do, I'm going to configure something for UDP traffic. So for UDP traffic, what I have to do, let me tell you. I'm going to configure this as my DNS server. Okay, I will create here some fake entries or like no entries here. So if I create here entry, it will send DNS query. Okay, it will inspect the traffic and here will be DNS reply at the in milliseconds. So at the same time entry will delete for UDP. So what I have to do, I want to just remain the entry here. So I don't want any DNS reply. Are you getting my point? This R1 will send DNS query to DNS server. So who is DNS server? R2. Okay, but I don't want R2 give the reply. Why? Because if R2 give the reply, my entry will be deleted as soon as possible. So I can't even see the entry for UDP traffic. But I want to show you how this firewall is inspecting UDP traffic. So just it will send and it will resolve it. Okay, so for the first time I will just show you, and then I will create here entry. Like I want to create here cisco.com or something like this. So on R2, R2 is my DNS server, right? IP DNS server. This is the command. IP domain lookup. Okay, and on R1 I will say who is your DNS server. IP name server 20.2. So just I created. Okay, and now I'm going to telnet it. Telnet the cisco.com. So cisco.com, R1 don't know who is cisco.com. So R1 know this is the DNS. So I will send DNS request to R2, right? So this is sending request to domain server. So at that time you can see the entry. See, we have UDP entry here, port number 53, right? Entries here. Okay, but the flags are not visible. Why? Still the traffic is not coming. So until unless I'm going to configure IP host cisco.com 2. Wait a minute, I did wrong. Okay, now maybe I will get the reply. Bad address, let me try again. So this time, yeah, it resolves my IP address. Okay, so now my entry will not be remain. Why? Because it created a telnet connection now. Yeah, we can see. Right. Maybe the last entry, I'm not sure because it happened around 40 seconds ago. That is the last entry, uh, at that time the DNS query was not resolved, right? That's why this entry is still here. So it will take some timeout because of the traffic. The entry is still here, okay? But for the second time there is no entry of UDP. Why? Because that entry is deleted as soon as your reply is coming to ASA, right? So that's why you have now here access. So that how you can check ASA is still inspecting the TCP and UDP traffic. But now what I'm trying to do, let me open it. I can show you one thing. Ping 1.2. So I try to ping. So ASA will create the entry, but it will not inspect the reverse traffic. You can see the ICMP traffic have entry in connection table. So ASA will create entry in con table, that is not issue. So when ICMP traffic is passing through, it will create the entry in con table, but when traffic is coming back, so they will never check the con table. Why? Because IP traffic is not inspected by default. That is separate thing, they create the entry in connection table, but I'm talking about the inspection. So how you can check that? Let's do one thing. Logging enable, logging console 7. Okay, now let me try to ping it again. So you can check deny inbound ICMP whenever source is 20.2 and destination is inside 10.1. So traffic is denied at that time. Why? Because there is no policy, or that traffic is not inspected by default. So by default IP traffic is not inspected, guys. So we have to inspect it, or we need to configure policy for that. Okay, so till now we just discussed about the TCP and UDP, but if I have such type of traffic, I need to inspect it. So what I can do, so for the first time I want to use my global policy and global ACL. Show run policy map. Okay, so here we have global policy. If you check, so I am moving into the global policy and global ACL. Okay, copy paste it, enter it. Here you have to use inspect ICMP and leave it. Okay, leave it. So now if you check show run policy, see inspect ICMP. So what is the command? If you check, this is the command. I move inside the global policy, under that I move inside the class which is inspection default, and I put this command inspect ICMP. I think this is clear, and this global policy is already applied on the device. This global policy is already applied in the global service policy. Okay, so you can check this is applied here. So now if you send the traffic, you can see we have reply and there must be entry, but I need to send traffic again. Come on. Yeah, you can see. So entry is here now, right? So ICMP traffic is inspected. So I hope this is clear to everyone how traffic is inspected on firewall this time. Guys,
Can you just go back small on the ICMP traffic?
okay. So
Yeah,
what
just
do you
that side.
what do you mean the slow? The traffic is going.
No, you know
Uh-huh.
the inspection of the ICMP traffic, the policy you created.
The policy. Okay, let me show you the policy.
Yes.
So I used the global policy which exists on the firewall. Okay, so firewall have default policy. The policy name is global policy. Okay, so policy map, global policy. Under that you have class map which have inspection uh, underscore default name. Under that I use inspect ICMP command. Okay, so after that if you check
Okay.
under the global policy, show policy map. Wait a minute. Show run policy, I think this command you need to check. Show run policy map, and here you can see global policy. Okay,
Okay.
and under that we just put this command, and now
Okay.
traffic is inspecting. So this is the first thing, you can use the
Okay.
global policy. But maybe you don't want to use the global policy, or you want to do some separate policies, like you want some changes, you want to allow and disallow some traffic, or maybe you want to limit the traffic. At that time we can use our own policies. I will show you how we can do that. Okay, but I hope this is clear till now.
Okay.
Okay,
No, this is fine.
yeah.
Yeah.
So now what is the next? I can remove this here, this one from here, and let me remove it. Okay, so I removed it, but still the global policy is applied on the device, right? So what I'm trying to show you this time, show run service policy. So I'm going to remove this policy now, just to show you. If we remove the global policy from the firewall, so will there any effect on TCP and UDP traffic inspection? No. So if you check now, the policy is not applied on the box, right? Policy is just existing on the device, but this is not applied. Why? Because I removed with this command, right? Okay, but now if I try to send some TCP and UDP data, still device is able to log in, right? If you check, there is no policy, but still we have enter in connection table. So that means TCP and UDP traffic is not dependent on the global policy. TCP and UDP traffic is not dependent on the global policy. But right now even my ICMP is not working. Why? Because I removed the ICMP, the first thing, and the second I removed the policy also, right? So even my ICMP is not working. So instead of apply inside the global policy, I can use this command, fix up protocol ICMP. So this protocol automatically, this command automatically allow the ICMP inside the global policy. If you check, now global policies automatically apply on the device also. See, now this is applied. Why? Because I put this command. Because of this command, the global policy is automatically applied on the firewall now. And if you remember, last time we removed the ICMP from the policy. Let me, yeah, see, yeah, here ICMP was there, right? So what I did, I removed this command, if you remember, right? And after that I removed the global policy also, just to show you TCP and UDP inspection. But now I did one command here, so because of that command, ICMP again allowed in the global policy, and global policy also automatically applied in the device. So now if you send ICMP traffic, it will allow. See, and if you check, show run policy map, it's here again. So I don't need to go inside the policy, I can just put fix up protocol ICMP. I did this command. Okay, so after this command, automatically server service policy is applied on the firewall in global mode, and now ICMP traffic is also applied. So now device is inspecting the TCP, UDP and IP traffic, guys. Which traffic? IP traffic. So what we can do after that, like we can control the traffic what is inspecting by the firewall. What I mean, like we can control the TCP traffic, or we can control the UDP traffic. Like I can control the number of TCP session, like how many TCP session they can create. So just suppose we have here multiple users, right? So this user is trying to take telnet of this router, and maybe there is also one more user that is also trying to take telnet of this router. So I can control only one device can take telnet at a time, right? So we can do that. So what I'm doing now, I can create the separate policies. Okay, so first of all I need to create ACL to match the traffic, guys. Okay, make sure what we need to do, we want to inspect the TCP traffic, so we need to create here ACL with access list command. I can give the name is like telnet. I want to inspect the telnet traffic. You have to permit the traffic, and source can be anyone like 10.1. Okay, wait a minute, or I can do I need to match the protocol, source any, destination any, and port number 23. So that is my telnet traffic, right? And now this thing you have to match inside the class map, which is CMap. Match access list, and access list is, guys, telnet. Okay, and now you need to move inside the policy map. Policy map is pmap for me. You can give any name. Okay, so I can remember these names, that's why I'm giving. You have to call the class map inside it, and here you have to give the inspect. And what do you want to inspect? I want to inspect the TCP traffic. Wait a minute, traffic is already inspected. So what we have to do, we have to do set connection. Okay, and I can control the max connection here with this command, right? Con max. So here is one connection for me. That means I just want to apply one connection or one remote connection at a time. Okay, not multiple. And now we have to apply this configuration under the service policy. Okay, the policy name is pmap. What is your policy name? Okay, and you want to apply on interface inside, because we want to configure this on inside interface. So that means what we did, we have matched that TCP traffic 23, and that we call inside the class map. Class map later on we call inside the policy map. Yeah, policy map have class map, and here we did set connection, and max connection is 1. That means if anyone trying to, okay, and later on we apply the service policy on my which interface, guys? Inside interface. Inside, that means, so whenever traffic is coming on inside interface, so this interface is going to check TCP traffic which have port number 23, right? And only allowed one TCP connection at a time for telnet traffic. For which traffic? Telnet traffic. So that we did here. Okay, but right now I don't have multiple routers. What I can do, okay, this is applied. I can show you here. Show service policy interface inside, and you can see we have service policy pmap which have class map, and we connect the max connection 1. Okay, so now I need to use one more router here. Okay, let me down the switch, so we can make it 10.2. okay, let me configure this router also. Okay, IP route. Okay, now we configured both the routers. So I have just inspected one connection at a time. So if I'm going to take telnet from this one R1, it can take telnet, admin and Cisco. But at the similar time, if I'm trying to access from R5 is also part of same LAN, traffic is coming to the this interface, and this interface have policy this time, right? See, just trying. So what you have to do, let me do one thing. Okay, I enabled the logs. Now see, connection limit exceed for input packet from 10.5, which is R5, right? On this port, with this port number for 20.2, on which interface, guys? Inside interface, that is not visible here, but the interface is inside. If I try again from R5, I can see again clear log message. See, the traffic is on interface inside. Okay, so that how we can see the traffic is inspected through the firewall, so we can limit the things, right? Okay, so you can see what policy we did here. So first of all, we create the access list. Access list is this one, which permit the TCP traffic and telnet port number, right? So you can see the 9 packets are matched with this ACL. Okay, and show run class map. We created here one class map which match the ACL telnet, this ACL, right? And after that we have show run policy map, and this is the default one. Here is R. This is the policy, right? And then we applied in the service policy. So that service policy we applied. I think this is clear to everyone, right? Guys,
Yeah, it's very clear.
okay, so that how you can inspect your telnet traffic. Okay, so similar, if you want to inspect your ICMP traffic, so currently ICMP is part of this, so it will allow all of traffic, right? So what I want to do, I have already like this policy map, so I no need to create multiple policy map, because one policy map P map is already allowed here, already applied on this interface. So just I can create other class map for ICMP traffic, and I can match and I can create ACL. So that class map I can make part of same PMAP ACL, sorry, PMAP policy. Okay, so we can inspect multiple traffic with a single policy, you can say. So what I want to do, I will remove the ICMP traffic from here, and I want to inspect this traffic now. So I will remove first it. Okay, now inspect ICMP. I removed it, and now I need to create ACL first because I want to match the traffic. Access list, the name is ICMP, and permit, and I want to inspect only from one this time. So this is my ICMP traffic from a host 10.5 to host 20.2, right? And now create the class map. Class map name is also, this time it should be different, so I'm using ICMP. Okay, and wait a minute, match access list name is ICMP. Okay, so this access this class map we have to match in the previous policy map. And what is the previous policy map, guys? Show run policy map. See, this time ICMP is not here, so I'm using this one, this pmap. Okay, and now under that class map is ICMP this time because we are using ICMP class map, and we want to inspect. Wait a minute. Ah, no need to say inspect because already traffic is matched, right? Yeah, we matched the traffic.
You are passing the ICMP traffic already, so.
Yeah, I need to say inspect, right? That is required. Inspect ICMP because ACL have ICMP traffic, and that ICMP traffic we have to inspect here. So you have to call it here also. So these are the commands. Okay, if you check what we did here, so don't be confused. So just we created ACL which match only this traffic. Okay, source is 10.5, destination is 20.2 ICMP traffic, and we create a class map name ICMP and match this ACL. Though above ACL is part of this class map, and later on this class map is part of the previous policy map, and under that we say inspect ICMP. That means if any traffic is coming in this class map, so you have to inspect ICMP traffic in that. And even we are only receiving the ICMP traffic, right? Because we match the specific ICMP traffic in ACL. So this time this yeah, yes please.
Wait. Let me just see. Wait.
Because what traffic I matched inside ACL, I have to inspect that traffic here.
Yeah.
So that
Okay.
what I configured, right? So that means
Yeah.
match this traffic and inspect this traffic in my policy, and that
Okay.
policy is applied already because this policy, this pmap have two policies now, one for telnet if you remember, one for ICMP. If I will show you globally, show run policy map. See, we have here global policy
Yeah.
pmap. It have class map that is matching the telnet connection one, right? And second class is ICMP which is inspecting ICMP traffic, because
Yeah.
you can configure only one service policy on interface. So I have configured service policy pmap, right? So pmap have now two
Yeah.
class map, so there can be multiple classes inside it like ICMP and telnet and SSH and UDP, anything. So there can be n number of class map inside this pmap which I want to
Okay.
inspect on my inside interface. Okay, so pmap is always one. Okay, but under pmap there can be multiple class maps, multiple ACLs in these class maps. Okay,
Yeah.
and now we can see if we try to ping from here, exit, there is no ping. Why? Because traffic is not coming from 10.1, right? If traffic is traffic is coming from 10.1, not from 10.5. My bad, this is the 10.5, it have to ping to 20, not 5. See, so that when 10.5 is sending data to 20.2, that is masked, right? And you can see ICMP connection from this to this is allowed, right? Okay, so is there any doubt, guys? And you can see the ICMP connection is denied from 10.1 to 20.2. Why? Because that is not in your inspection. That is not in your inspection. Okay, so just I'm explaining here. Firewall inspect by default TCP and UDP traffic, but even TCP and UDP traffic you can control, right? And for ICMP traffic you can create the separate policies so they can match the traffic and forward it. So I guess this is clear to everyone how firewall is inspecting the traffic here. Okay, so if this is clear, I'm moving with the next topic, guys.